Hello everyone, welcome back to my YouTube channel Physics Unification. In the last chapter, we developed the concept of position, displacement, velocity, and acceleration that are needed to describe the motion of an object along a straight line. For one dimension, directional aspects can be taken as positive or negative signs, but in two or three dimensions, we need to use vectors. Therefore, it is necessary to learn the concept of vectors. Then, what do you mean by vectors? How to add it, how to subtract it, and how to multiply it? That one we have to learn. For those concepts, we have to learn the chapter motion in a plane. More than one dimensions, we have to learn the chapter motion in a plane. We know that aeroplane which is moving in three dimensions. For that one, we have to learn this chapter. So in this chapter, these are main contents we are going to learn. First one it is scalars and vectors and those difference, multiplication of vector by real number. Next one it is vector addition, subtraction of vectors. Next one relative velocity in two dimensions, projectile motion. Last one it is uniform circular motion. First concept it is scalars and vectors. We already know scalars means which has only magnitude but not directions. Vector means which has both magnitude and directions. Now we have to differentiate both the quantities. Scalars, it has no directions. In vectors, it has directions. Scalars can be added by simple arithmetic ways, but vectors cannot be added by simple arithmetic ways. Scalars cannot be represented graphically. For vectors, we can represent it as graphically. Fourth point, example for scalar it is mass and density. For vectors, example, which has both magnitude and direction means velocity, we can take it as vector quantity, and acceleration, we can take it as vector quantity. And this difference is very important for 2 marks. Next one concept is equality of vectors. If we consider two vectors, vector A and vector B, which are said to be equal if and only if they have same magnitude and same directions. Means it should have same magnitude and same directions. Then we can said to be that vector it as equal. So let us consider vector A and vector B, which we can take it as equal vectors because which has same magnitude and same direction. But in this diagram, vector A is not equal to vector B because which has only magnitude, same magnitude but different directions. Next it is multiplication of vector by real number. Multiplying a vector A with a positive number lambda. Vector A na lambda ಅನ್ನೋ ರಿಯಲ್ ನಂಬರಿಂದ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ರೆ which gives a vector whose magnitude is changed by the factor lambda. Magnitude lambda factor ಇಂದ change ಆಗಿರುತ್ತೆ but the direction is same as that of vector A. That is lambda into vector A. Magnitude of lambda into vector A is equals to lambda into vector A. Let us consider example. First example, if vector A is multiplied by 2, we get 2 into A is same direction, which has same direction and has a magnitude twice of vector A. Let us consider second example. Here vector A is multiplied by -1 or -1.5. It gives a vector -1 vector A or -1.5 vector A in opposite direction and whose magnitude is minus lambda times of vector A. Next concept is vector addition. In vector addition, triangular law of vector addition and another one parallelogram law of vector addition, both which carries for 3 marks for the final examination. Let us discuss triangular law of vector addition. Statement: if two vectors can be represented in magnitude and direction by the two sides of the triangle taken in the same order, then the resultant is represented both in magnitude and direction by the third sides of the triangle taken in opposite order. ಏನು ಹೇಳುತ್ತೆ ಇದು? If two vectors, let it be vector A and vector B, is represented in magnitude and direction by the two sides of the triangle which are taken in same order, then the resultant is represented, R ಅನ್ನೋದೇನು resultant, both in magnitude and direction by the third side of the triangle which are taken in opposite order. ವೆಕ್ಟರ್ ಎ, ವೆಕ್ಟರ್ ಬಿ, ಆರ್ ಅನ್ನೋದು ಅಪೋಸಿಟ್ ಆರ್ಡರಲ್ಲಿ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡಿರ್ತೀವಿ. ದಟ್ ಈಸ್ ಒ ಪಿ ವೆಕ್ಟರ್ ಪ್ಲಸ್ ಪಿ ಕ್ಯೂ ವೆಕ್ಟರ್ ಇಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಒ ಕ್ಯೂ ವೆಕ್ಟರ್, ಆರ್ ದಟ್ ಈಸ್ ವೆಕ್ಟರ್ ಎ ಪ್ಲಸ್ ವೆಕ್ಟರ್ ಬಿ ಇಸ್ ಈಕ್ವಲ್ಸ್ ಟು ವೆಕ್ಟರ್ ಆರ್. This one is the triangular law of vector addition. Clear ಆತಾ? Next one it is parallelogram law of vector addition. Statement ನೋಡುವ. If two vectors acting at a point can be represented by the two adjacent sides of the parallelogram, both in magnitude and direction, then the resultant is represented by the diagonal of the parallelogram both in magnitude and direction starting from that point. ಏನು ಹೇಳುತ್ತೆ ಇದು? ಟೂ ವೆಕ್ಟರ್ಸನ್ನು ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ ವೆಕ್ಟರ್ ಎ ಆ್ಯಂಡ್ ವೆಕ್ಟರ್ ಬಿ ವಿಚ್ ಈಸ್ ಆ್ಯಕ್ಟಿಂಗ್ ಎಟ್ ಅ ಪಾಯಿಂಟ್ ಓ, represented by the two adjacent sides of the parallelogram both in magnitude and direction. Then the resultant ಅಲ್ಲಿ represent ಮಾಡ್ತೀವಿ by the diagonal of the parallelogram both in magnitude and direction starting from that point. That is vector A plus vector B is equals to vector R, which is equals to OP vector plus OQ vector is equals to OS vector, or OP vector plus PS vector is equals to OS vector. This one is the parallelogram law of vector addition. Triangular law of vector addition and parallelogram law of vector addition, which both carries 3 marks. Next one concept it is vector addition. We know vector addition it is commutative. A plus B is equals to B plus A. Vector addition is associative. A plus B plus C is equals to A plus B plus C. And also we know the concept of subtraction of vector. That is, if we consider two vectors, vector A and vector B, addition of two vectors which gives R1 is equals to vector A plus vector B. That is subtraction of vector which gives R2 is equals to vector A minus vector B. This one is the subtraction of vector. Next one it is derivation of expression for magnitude and direction of the resultant of two vectors, vector A and vector B, in terms of their magnitude and angle theta between them. Let us consider two vectors. See, this derivation is important for 3 marks. Let us consider two vectors, vector A and vector B. Vector A and vector B acting at a point O. Let theta be the angle between them. From the parallelogram, how we have to write? A is equals to vector OP, B is equals to, which is parallel to PS, and which is equals to OQ. Means vector B is equals to OQ vector and PS vector. Then vector R is equals to, that one is the resultant. We have to derive this expression for R. R is equals to O into S. Now consider the triangle ONS. Let us consider the triangle ONS. We know Pythagoras theorem, that one is OS square. Just apply Pythagoras theorem for the triangle ONS. OS square is equals to ON square plus SN square. But ON can be written as OP plus PN. And OS square, OS means resultant R. OS square can be written it as R square is equals to ON square means OP plus PN whole square plus SN square, which is equal to means R square is equals to, we know the formula, A plus B whole square is equals to A square plus B square plus 2AB. Means how we have to write this one? OP square plus PN square plus 2 into OP into PN plus SN square. Now just consider one triangle PSN, means SPN triangle, that is SPN triangle. From this SPN triangle we can write it as value of PN is equals to, that one is adjacent side. So for adjacent side we have to apply cos theta. We have to calculate the value of PN and SN from the triangle SPN. So for PN, that one is adjacent side, so we have to apply cos theta for this one. Cos theta is equals to adjacent side divided by hypotenuse. Which one is adjacent? PN is the adjacent. PN divided by hypotenuse is PS. Therefore, value of PN is equals to PS into cos theta. Cos theta. So value of PN is equals to PS is value of B, means vector B. B cos theta. In the similar way, sin theta can be written as sin theta is equals to opposite divided by hypotenuse. Which one is the opposite? Sn is the opposite. Sn divided by PS. So Sn is equals to PS. PS is PS into sin theta. Value of Sn is equals to vector B into sin theta. So now this expression changes. As R square is equals to OP square plus PN square ಮತ್ತು SN square ಅನ್ನು ಒಂದು ಸೈಡಲ್ಲಿ ಬರೆದಿಟ್ಕೊಳ್ಳಿ. PN square plus SN square plus 2OP into PN. So therefore R square is equals to OP square. OP square ಅಂದ್ರೆ ಏನು? Vector A whole square. Vector A square plus PN square plus SN square. PN square plus SN square is equals to PS square, which is by Pythagoras theorem. PS square plus 2 into OP into PN. So therefore vector R, this is vector resultant which is in vector form. Vector R whole square is equals to vector A whole square plus PS is equals to vector B whole square plus 2 into OB is vector A into PN. We know value of PN is equals to B cos theta. Vector B cos theta. This one is the expression for resultant of two vector A and vector B in terms of their magnitude and angle theta between them. This is called as law of cosine. Law of cosine anta idanna ಹೇಳ್ತಾರೆ. Now we have to calculate the magnitude which is over, so means we have to find out the direction formula, direction value of direction. Let us consider alpha, which is the angle made by vector r with vector a. By the triangle ONS, tan alpha is equals to, tan alpha means opposite divided by adjacent. Which one is opposite here? SN divided by adjacent is ON. SN divided by ON. And we know SN is equals to vector B sin theta. Just apply it here, which gives tan alpha is equals to, now tan alpha is equals to Sn by On. We know Sn is equals to B sin theta and Pn is equals to B cos theta. Here how we have to write On? On is equals to OP plus Pn. Therefore tan alpha is equals to Sn by, in place of On we have to write it as OP plus Pn. Therefore tan alpha is equals to B sin theta, because Sn value is B sin theta, divided by vector A plus Pn is B cos theta. And this one is the final expression for the direction of the resultant vector. Up to here, which carries 3 marks for the final examination. Next one, it is vector addition by analytical method. If you consider vector A is equals to AXI cap, AYJ cap, AZK cap, and vector B is equals to BXI cap, BYJ cap, and BZK cap. Vector addition means addition of the both the vectors, which gives by analytical method resultant R is equals to vector A plus vector B. So in place of A, you have to write it as value of A. In place of B, B value we have to substitute. So after substituting, what we will get finally, here I cap is common. So remaining terms is AX plus BX. AX plus BX I cap, here AY plus BY J cap plus AZ BZ K cap. This one is the vector addition by analytical method. Now we have to know the displacement concept. Let us consider a point P, which is displaced from P to P dash, and OP is equals to R, OP dash is equals to R dash. R and R dash are the position vectors. Let us take in this, join this P and P dash on X and Y axis. The difference of P and P dash, which gives the small change in position vector delta R, and along X axis, which gives delta X. Along Y axis, change in position of the particle, which gives delta Y. Then how we have to write initial position vector? That one is OP, which is equals to R vector, which is equals to xi cap plus yj cap. Now how we have to write new position vector? OP dash. OP dash is equals to R dash vector, x dash I cap plus y dash j cap. Therefore displacement of the particle can be written as PP dash is equals to, PP dash is the displacement of the particle, which is equals to the value of delta r, change in the position vector, which is equals to r dash minus r, and value of r dash is equals to x dash I cap plus y dash g cap minus of r is equals to x I cap plus y g cap, and finally we will get x dash minus x I cap is common plus y dash minus y j cap. This one is the displacement of the particle. Next one is velocity. Velocity can be defined as change in displacement to the time taken. We know delta r is equals to x dash minus x I cap plus y dash minus y j cap divided by delta t. Here x dash minus x can be written as delta x I cap plus y dash minus y can be written as delta y j cap whole divided by delta t. Therefore, velocity v is equals to delta x by delta t I cap plus delta y divided by delta t j cap, which is equals to vx I cap plus vy j cap. This one is the expression for velocity. Next one, it is instantaneous velocity. How we have to define instantaneous velocity? We already know it is limiting value of the average velocity as the time interval delta t tends to 0. We have to apply limit to the velocity value. So vector v is equals to limit of delta t tends to 0 delta r by delta t, which is equals to, just by applying limit to the delta function, we will get dr by dt. So v is equals to I dx by dt plus j dy by dt. dx by dt can be written as vx I cap and vx I cap plus vy j cap. Next one concept, it is acceleration. Acceleration can be defined as, which is change in velocity to the time interval. Change in velocity can be written as delta vx I cap plus vy j cap divided by delta t. Delta vx by delta t I cap plus delta vy divided by delta t j cap. So in the similar way, instantaneous acceleration can be written as limiting value of the average acceleration, which is equals to ax I cap plus ay j cap. And finally, we have to write it as like this. Next, how we have to write relative velocity in 2 dimensions. If you consider 2 dimension, one is related to another and another one is relative to first one. Then how we have to write? In this way, we have to write, say, velocity of object A relative to B. A object B ಗೆ relative ಆಗಿದೆ. ಆವಾಗ velocity ಏನು ಚೇಂಜ್ ಆಗ್ತದೆ? ಹೇಗೆ ಬರಿಬೋದು ನಾವು? VAB is equals to VA minus VB. Similarly, velocity of object B relative to A. ರಿವರ್ಸ್ ಇದೆ ಅಂತ ಅರ್ಥ. ಆವಾಗ ಏನಾಗ್ತದೆ? VB minus VA. Here, just by seeing this one, how we have to write? VAB is equals to minus of VBA. And magnitude of both the quantities are equal to each other. This one is the velocity of relative velocity. Okay. What we discussed in this video: difference between scalars, vectors, equality of vectors, multiplication of vectors by a real number, vector addition, ಅದರೊಳಗಡೆ ಯಾವುದು triangular law of vector addition, parallelogram law of vector addition, ಅದು ತುಂಬ ಇಂಪಾರ್ಟೆಂಟ್ ಇದೆ. ನೆಕ್ಸ್ಟ್ ರಿಸಲ್ಟೆಂಟ್ ಆಫ್ 2 ವೆಕ್ಟರ್ಸ್ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಆ್ಯಂಡ್ ಡೈರೆಕ್ಷನ್, ಇದು ಕೂಡ ತುಂಬ ಇಂಪಾರ್ಟೆಂಟ್. ಲಾಸ್ಟ್ ವೆಕ್ಟರ್ ಅಡಿಷನ್ ಬೈ ಅನಾಲಿಟಿಕಲ್ ಮೆಥಡ್. ನೆಕ್ಸ್ಟ್ ಕಾನ್ಸೆಪ್ಟ್ ಆಫ್ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್, ವೆಲಾಸಿಟಿ ಆ್ಯಂಡ್ ಎಕ್ಸಲರೇಷನ್, ಹಾಗೆ ರಿಲೇಟಿವ್ ವೆಲಾಸಿಟಿ ಇನ್ 2 ಡೈಮೆನ್ಷನ್ಸ್. ಇವೆಲ್ಲ ನಾವು ಈ ವಿಡಿಯೋ ಒಳಗೆ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ವಿ, ಸ್ಟಡಿ ಮಾಡಿದ್ವಿ. ಐ ಹೋಪ್ ಯು ಅಂಡರ್ಸ್ಟುಡ್ ದಿಸ್ ಟಾಪಿಕ್ಸ್. If you have any doubts regarding these topics, please drop a comment in a comment box. ನೆಕ್ಸ್ಟ್ ವಿಡಿಯೋದೊಳಗೆ ನಾನು ಪ್ರೊಜೆಕ್ಟೈಲ್ ಮೋಷನ್, ಅದರಲ್ಲಿರೋ ಎಕ್ಸ್ಪ್ರೆಷನ್ಸ್, ಟೈಮ್ ಆಫ್ ಫ್ಲೈಟ್, ಹೊರಿಜಾಂಟಲ್ ರೇಂಜ್, ಮ್ಯಾಕ್ಸಿಮಮ್ ಹೈಟ್ ಎಕ್ಸ್ಪ್ರೆಷನ್, ಹಾಗೆ ಲಾಸ್ಟ್ ಸೆಂಟ್ರಿಪಿಟಲ್ ಆಕ್ಸಿಲರೇಷನ್ ಡಿರೈವೇಷನ್ಸ್ನ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತೀನಿ. ಅವು ತುಂಬ ಇಂಪಾರ್ಟೆಂಟ್ ಇದೆ. ನಾನು ನೆಕ್ಸ್ಟ್ ವಿಡಿಯೋದೊಳಗೆ ಅದನ್ನು ಕ್ಲಿಯರಾಗಿ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತೀನಿ. ಹಾಗೆ ನಿಮಗೆ ಈ ವಿಡಿಯೋ ಹೇಗೆ ಅನ್ನಿಸ್ತಿದೆ ಅನ್ನೋದನ್ನು ಪ್ಲೀಸ್ ಕಮೆಂಟ್ ಬಾಕ್ಸಲ್ಲಿ ನನಗೆ ಕಮೆಂಟ್ ಮಾಡಿ ತಿಳಿಸಿ. ಥ್ಯಾಂಕ್ ಯು. ಸ್ಟೇ ಟ್ಯೂನ್ಡ್. ಲೈಕ್, share and subscribe Physics Unification channel. Thank you.